Okay, so we're going to do this question twice. We're going to do it the first time for the question that's actually written there, and then we're going to do it the second time for the question that they have answered in the response in the ISMG. Okay, so when we're determining the line y equals mx that divides the area underneath this curve over 0 to 2 into two regions of equal area, justify all procedures and decisions by explaining mathematical reasoning. Evaluate the reasonableness of your solution. So first thing we're going to do is we're going to calculate the area, the total area. Calc total area. Now to do that, I'm going to integrate my original function over our boundary of 0 to 2 with respect to x. And as you can see, I did that in my calculator over here, and it gave me 4. So, therefore, we want area under the function to equal 2. Now, in the question that they've written here, this is pretty easy. What kind of function is this? If you look at it, or if I expand the brackets, you can see that it is going to be a linear function. So why don't we start by sketching? Okay, and you'll see why I'm doing this in a moment. So there's 0, there's 2. So we're going to let x equals 0, find out our first coordinate. So 2 minus 0 equals 4. So when x is at 0, y is at 4. Okay, and our next one is going to be when x equals 2, y equals 0. So that's my other coordinate. So now we can join them with a line. So the area under that total thing there is 4 units. Now, we want to change it so that we have the area that goes between these two. Pretend that worked out for me. That area underneath this curve is half of that original one. So really what I'm looking for here is half of the area of a triangle. Okay, so let's think about the area of a triangle. Is half of base times height. So that means we want 1/2. The base is going to be 2, and we're just going to leave height as what it is, or we're going to call it A. So the base is times 2, the height is just A, and we want the area to be equal to 2. So equals 2. So first things first, cancel, cancel. I'm left with A equals 2. Okay, so now I've got this coordinate here. So that coordinate coordinates of y equals mx is going to be made up of 2 and 0 and 0 and 2. So now to find the gradient, to calculate the gradient, all I have to do is throw it into rise over run. So it goes up 2 divided by 2, and the gradient is negative. So it's going to give me an answer of -1. But if you wanted to use our old formula that we use, that looks like this. y2 minus y1 over x2 minus x1. That's going to give me 2 minus 0 divided by 0 minus 2 equals -1. So therefore, our function is y equals -m. Now, that is the question that's actually stated. That's not the question that they've actually written. The other step that I could do to verify by testing the integral, that should be an x, of -x dx over 0 to 2 equals 2 units. That would test and prove that that is true. Okay, so that is the question that is written here. When you look at the solutions, though, that's not what they've given us. So I'm now going to rub this out and we're going to go again, but for the question that they've made up themselves. Okay, we're just going to try and lasso this whole thing. Delete, see you later. Okay. So what's the difference between the question that they gave us and the answers? Now, in the answer one, the function that they've used is 2x minus 2x like that. So this changes things because now we've got a quadratic function. So over here, I'm going to do my same first step, calc the total area. And that's going to be equal to, over here, I'm going to change this by putting another value of x in there, execute, and now we've got the total area is equal to 8/3 units squared. And we did that in the calculator by integrating. It's important to state what you put in your calculator to get those marks if something goes wrong. Okay, dx. Therefore, the integral, therefore, area is 4/3 units squared. That's what we're trying to test for. Okay, so next thing that we're going to do is we're going to think about our problem. So half the area is 4/3 units. Okay, so this is what it looks like. Whee! So there's 0, there's 2. Now, the total area underneath here is 8/3 units. We want to find, now this has got a intercept there of 0, 0, goes up to there like that, and our function for that is y equals mx because it is a straight line. So we need to calculate this point here. Okay, that point there is A, and that is the point where if I integrate the top of the function, we'll get what we want to get. Okay, so first things first that we're going to do is we're going to set up our equation. So we're going to be integrating between 0 to A. Okay, now if you think about this as composite shapes, I want to do the big one minus the little one, and that's going to leave me with that slither at the top here. So it's going to be the top function, 2x bracket 2 minus x, subtract the lower function, mx, all with respect to x. Okay, so that's what we're integrating. So currently I don't know what the gradient is, I don't know what a is, and I've got my x's there. Okay, so now all I'm going to do is I'm going to expand this, and I know that this whole area should be equal to 4/3 units squared. So let's just do that now. Now this will be 4x minus 2x squared. So when I integrate, it'll become 2x squared, because the 2 will come down, divide the 4, making that a 2, minus 2/3 x cubed minus mx squared over 2, all with a over 0, equals 4/3 units squared. Okay, so I'm going to substitute in the a and I'm going to substitute in the 0, and we're just going to see what we're left with. So when I substitute in a, I get this. Okay, and subtract, when I substitute 0 in, this term's gone, that term's gone, that term's gone, so I can just leave it like this. Now, I can't solve at the moment because I've still got too many unknowns. So I'm going to have to think about this in another way. Now, I can see that these two functions here share a point where they're touching. Okay, so I'm going to find the point of intersection. Now, find the point of intersect. And the reason I'm doing this is that will tell me the x value for a. So find the point of intercept, let y1 equal y2, meaning that y1 is 2 bracket 2 minus x is equal to mx. Now I can rearrange, that's missing an x. So that's really 4x minus 2x squared. And if I divide this by x, I'll be left with it in terms of m. So cancel, cancel, cancel. 4 minus 2x equals m. And we're going to let x equal a, because if I'm trying to find that, that is the point here where that's a. So my x value is really a. So now I know that 4 minus 2a is equal to m. And I'm going to sub that back in. So now I've got 2a squared minus 2 over 3a cubed minus 4 minus 2a squared, all divided by 2, is equal to 4 over 3. So I'm going to punch this in my calculator using my favourite thing, solve n. Options, calc, solve n, 2. I'm just going to change these to x squareds in the calculator. Minus 2x squared over 3 minus bracket 4 minus 2a bracket x squared all over delete 2. Next, shift equals 4 over 3. Now you have to put put that in the wrong spot. That's what happens when you're not looking when you're typing. Shift equals 4, 3. Now you've got to put the comma x in. Sometimes it'll work fine for you. Other times it won't. So just put the comma in. Exit. This is different to what I got in my book before. So let's just double check our working here. I think I've put something in the calculator incorrectly. Let's just double check. So minus 2x, that should be a 3. That's where I've gone wrong. Okay, execute. That's better. Okay, so now we've determined that A is equal to 1.5874. Okay, so now we can calculate the gradient because, no, we can't. We need one more thing. We know that this point here is when A, or X, is 1.5874, but we need the Y coordinate so we can substitute it in. So calc gradient. So first coordinate will be 0, 0. Next coordinate is going to be 1.5874. Now we need to find that other one. When X is that, what is Y? So if they are simultaneous or they are intersecting, then that means they're touching at the same point. So if I put in that original function, 2x, bracket, 2 minus x, bracket, execute. Now I'm going to draw this. Now I'm going to G-solve, go across. We want to calculate y because we've got a value of x. Okay, so when x is that, y is 1.3099. G-solve. Okay, so obviously if I had more space, I would write about how I put that in the calculator to determine that second coordinate because it's asking me to evaluate and justify all the procedures. I just don't have the space here. This little pad thing is really hard to write with. Okay, so now I can substitute it in. So it'll be y2, 1.3099 minus 0 over 1.5874 minus 0. That will give me my gradient, which when I punch that in the calculator will give me 0.83. Therefore, my function is y equals 0.83x. Now we're going to verify. So to verify this, I'm going to go into this graphing function, and I'm going to put my function in there. Execute, draw. Now, when I integrate between the two, I'm going to gsolve, go over here, integrate between the intersection points. So the first one is at 0 and y, execute, then press across. The next one will be at that next coordinate. So you can see there's x, there's y, execute, and the answer to this should give me half of the area from above. Now I've got a slight rounding error because I haven't used exact values, but you can see it's pretty damn close to being 1.333 recurring, which is 4/3 units. So verified, I would explain what I just did there.